What is geology? That's the basic things. The study of earth science, study of rocks, study of minerals, study of structures, geological structures. Say for example, folds, faults, joints, and unconformities. That is the overall outlines of the engineering geology. Why we are going to study the engineering geology? What is the importance of engineering geology in a civil engineering practice, civil engineering projects? Whatever the projects you are going to take up, okay, those projects first, the initial investigations, initial the survey which you need to carry out, that's a geological survey. Different rock types, different minerals, different structures, geological structures, and hydrogeology. Okay, what is there in the subsurface? I mean, groundwater movement, surface water movements. Okay, and remote sensing and GIS part. That is latest technology which we involved in the thesis. Okay, so these are the the engineering geology is the basic for the civil engineers. Okay, for any type of project, if you are going to take it, first thing is what type of rocks, what type of minerals, what is there in the subsurface, below the surface, what is there. Okay, because the raw material is required. You need the raw material to construct a, the infrastructure, construct a building, construct a road, railways, tunneling, okay, reservoir, dam construction. You need the raw material. Where it is coming from? It is coming from the earth. How you are going to do the mining, okay, and where it is available, how it is available, for which for which project, what type of the raw material is required. So all things coming from the engineering geology part. How you are going to select the building stones, how you are going to select the construction materials. Okay? Those things are coming. It's a foundation for the civil engineers. This is coming from the engineering geology. Okay, this is the overall concept of engineering geology for you guys. So now let's go to the in the last week we discussed the what is the application of engineering geology, and next part is what is the internal structures of the engineering geology. What is the internal structures of the earth? The crust, mantle, and core that we discussed there. Okay, in the crustal part, what are the different heterogeneous materials are there. In the mantle part, what is the the materials are there, how it behaves, and central core, central part of the earth, that's called a core. Let me share you the entire screen so that it will recap you the in the last year. Okay, okay, it's presenting now. The screen is moving. Okay, yeah, can you see the screen now? Screen is visible there. Hello.
Yes, sir.
Okay, right. Right. So here, the major, internal structures of the Earth that we discussed there, crustal mantle and core part, and these are all the different, internal structures of the Earth, different layers. Okay, and what is there in the crust, mantle, and core that we discussed there, and this is a cross section of the internal structures of the Earth. Okay, what is the depth? 30 to 40 meter, for 30 to 40 kilometer. That is a crustal part. 2009 up to 2,900 kilometer for mantle part, and 6,000 to 6,370 kilometer. That's called your central part of the Earth. This is how it, internal structures of the Earth, and it's a composition, mineralogical composition. What are the minerals are there? Those things we studied in the last year. It's a very interesting where we are doing, how we are doing, where is the raw material for construction. Those things are coming from the topmost shell of the Earth. That's called a crustal part. Okay, where it is available, how it is available, we'll discuss in the next class. Okay, now let's go to the mineralogy. So what is there in the mineralogy? It's the study of minerals. Okay, so what is there in the what is mineralogy? The first definition. What is mineralogy? And describe the different types of mineral properties. Mineralogy, minerals. It's a naturally occurring substances which is having the specific chemical composition and internal atomic structures. Definite, perfect internal atomic structures. Okay, so this is a definition of minerals. Minerals have defined as a naturally occurring substances, okay, that are characterized by the definite chemical composition and internal atomic structures. That is a definition of minerals. Okay, since the rocks which makes up the earth are simply natural aggregates of minerals. So when it comes to the petrology, study of the rocks. Petrology means study of rocks. So it's an what is a rock? It's an aggregate of minerals. Okay, that's aggregate of minerals. What is a mineral? Specific chemical composition and internal atomic structures. Okay, these are the fundamental importance of the understand the elements of science of geology. Okay, mineralogy. Okay, now let's go to the how we are going to identify the minerals. How we are going to identify the minerals? What are the physical properties of minerals? So first of all, let me show you some of the minerals there, how the minerals are working basis. Then you can easily understand the what is there in that part. Okay, let me go back to the some videos or those things and yeah. Okay, right. As we discussed there, uh, on the earth, the first formed rock is the igneous rocks. I told you that. Let me give the outline of the rocks and minerals there. And these are all the igneous rocks. These are all the igneous rocks, and these are the granites, which maybe you have seen that. Okay, these are the granites, and this is a basalt. Sorry, granites, gray granite. Okay, black and white, and it's a pink granite. And here is okay. Okay, this is a pink granite, gray granite, and black granite. What we are using in the house for the construction of buildings. And this is a basalt. It's a completely a volcano eruption. During the volcano eruption, these basalts are formed. This may be the massive volcanoes. Sorry, massive basalt, vesicular basalts, because of there is a holes in the basalt. That's called a vesicular basalt. And these are amygdalar basalts. There are different types of basalts. Okay, and here is the pegmatite is there, and it's what do you call this granite, and this is pumice. That's it. These are the igneous rocks. These are the specimens, rock specimens, but it maybe looks in a different way in the fields. Okay, same thing. And these are all the sedimentary rocks. Okay, I told you that the first formed rocks from the earth during the volcanic eruption time, igneous rocks. Okay, and sedimentary rocks, these rocks are formed from the existing rocks, from the igneous rocks. So due to a weathering, transportation of the disintegration of this particle, these rocks, and gets eroded, transported, and deposited in the a very suitable place. Sediments means grains. Okay, it's together, making together and compacted. That's called the sedimentary rocks, like sandstones. It's a rich of silica sands. Okay, and it's a laterite. Okay, okay, and here is the quartzite, and it's a marble. Okay, and it's a gneiss. So these are all different rocks. Okay, okay, these are all the the sedimentary rocks, and these are all the metamorphic rocks. Metamorphic rocks are formed from the sedimentary as well as the igneous rocks. So how it is, they change the original position, sorry, the chemically and physical appearance of the surface due to high temperature and pressure condition of the surface. So first formed rock is igneous rocks, and second one is sedimentary rocks, and third one is the metamorphic rocks. Metamorphic rocks are formed from the pre-existing rocks. What are those pre-existing rocks? Sedimentary and igneous rocks. Okay, don't get confusions. Okay, so these are all the rocks. Okay, so now let's go to the mineral part. How the minerals are looks like this. I would say it's okay. Let's go to the some of the middle part so that you can get some interest on this properly. Okay, see here. These are all the quartz minerals, like a white minerals. Varieties of quartz will be there. These are all useful for manufacturing of glasses. Okay, and these are all called. Okay, can you hear my voice? Deepthi, Darshini, Chiranjeevi, Bharat.
Yes,
Yes,
sir.
sir.
Was it audible?
Yes,
Can you
sir.
see the
Yes,
minerals,
sir.
mineral photos?
Yes, sir.
Okay, just I'm giving the outline
Yes,
of
sir.
that, minerals and rocks, so that you can say easily, you can, understand the what is the physical properties of rocks, how it looks and how it is. Okay, these are all the naturally occurring rocks and minerals. There is no artificial, there is no man-made these things. Okay, these are all the naturally occurring minerals on the Earth surface. Okay, these are all the quartz. Okay, this may be a rosy quartz because it's a rose color. It's a smoky quartz. It's a gray color, and it's a white quartz. It's also we call it as a uh, milky quartz. It's just like a white, transparent 100%. These are all useful for manufacturing of glasses. Okay, it's a very important, and these are all the feldspar group of minerals. Generally we use this minerals, microcline, orthoclase, plagioclase. These three minerals useful for manufacturing of ceramic and sanitary products, ceramic products. Okay, these are all the raw materials what I am showing. These are all the minerals which are used as a raw material for manufacturing of the different products. Knowingly, unknowingly, you are using the natural resources, maybe a rock, maybe the minerals, but we don't know that where it is coming, how it is coming from. Okay, and this is a thing of the iron ore, hematite, and the magnetite. Hematite and magnetite, generally we use it for extraction of iron and steel, iron and steel manufacturing units, to construct the buildings, to construct a dam, reservoir, road, metro station, everything civil engineering product, steel is required. Where it is coming from the steel? It is coming from the hematite and magnetite. These are all iron ores. Okay, we extract these minerals from the mine, from the earth. Okay, how we are doing? What you call this? Drilling, blasting, and crushing units. Okay, that's the thing that we'll discuss in the later part. This is a raw material. This is a hematite ore, right? This is a magnetite. These two are minerals extracting for iron and steel, manufacturing of iron and steel. Say, for example, Jindal Iron and Steel, Torangallu, in the near Hospate. Okay, like that, Tata Steels are there, like Kalyani Steels. There are many steel plants are there in India, and like that, many iron ore mines are there in India. That we'll discuss in the later stage. So this is a product of that, and this one is the mica. This is another mineral, mica. Generally, we use this mica for electrical industries because of high heat resistance. High heat resistance. We use this mica for your in the iron box. Generally, you see that when you open the iron box, there is a one layer called mica layer, because the power is not directly connecting to the bottom plate of your iron box. Power is generally transmitted through this the mica plate, mica layer. Okay, that's why it's not get more shock from that. Generally we use this mica from the mica in the electrical industries. Okay, yes, and these are the copper ores. So it's a pyrite and it's a chalcopyrite. Okay, pyrite generally it's a foolish gold. It's look like a gold metal, and chalcopyrite we use it for extraction of copper ore. Okay, This is how it looks, the things of, the minerals and rocks. Okay. These are all the specimens which you use in the lab, right? Let's go back to that. Go back to the rocks and minerals. Okay, you understand. First is the rock, which is aggregate of minerals. Okay, what is the mineral? Mineral is the specific, it's a natural occurring substances which is having the specific chemical composition and internal atomic structures. Okay, so now let's go back to the things called how these minerals you can identify. I'm a geologist. I can easily identify the minerals because I studied the geology. Okay, so how you are going to identify the minerals? It's a very simple. It's a very simple. So first we need to understand. These are the set of the mineral properties. First one is the color, how it looks, the color, the mineral color, and habit or form, how it is in the shape. What is a shape in the sense it may be a bulky or it may be what you call this crystals, looks like a crystals, or it may be any other shapes. Okay, that's called form. And the streak, what do you mean by the streak? Streak is nothing but when we need to identify the color of the mineral may be the white, where there is a streak plate, we call it as a streak plate. So when you rub with the streak plate, that releases the different color of the mineral, or it may be release the same color. That's called a streak. Some minerals are release the same color, some minerals are release the different color. That's a streak. And what is a luster? Luster is the shining of the minerals. Say for examples, I would say it's, yeah, this this is a orthoclase, microcline, and plesioclase minerals. Okay, or it may be it's a quartz group of minerals, rosy quartz, smoky quartz, and what is this, milky quartz. So how these minerals are looks like this? What is luster? Whether it's a vitreous, the surface of the minerals, whether it is shining or not shining. Though this rosy quartz and milky quartz, these two are shining very perfectly, but the smoky quartz, the middle one, it's a little bit dull. It's not a vitreous. Say in the luster, there are three categories. The one is called vitreous luster. If it is shining more of the mineral, that's a vitreous luster. If it is a little bit partially shining, it's not 100%. That's called a subvitreous. And some are like I would show you that. Yeah, this is completely dull. I don't know. It's a black color. It's a completely dull. There is no shining on that. That we call it as a dull luster. Vitreous, subvitreous, and dull luster. There are three types of lusters will be there. That's another property of the minerals. And the cleavages. Cleavages are the weaker zones of the minerals that you can easily identify from the minerals. What are the weaker zones? Okay. So here, I would say this. See here, you can see this. The cracks, this thin vein of the weaker zones, like a hair, like fracture. That's called your the cleavages. When you break these minerals, it will perfectly break through the cleavage part. Okay, like this. Some are cutting properly, some are abnormal. The cutting the things. And cleavage and fracture, there are different types of cleavages, whether it is there or not. That's all. Present or absent cleavage. That's only two categories. And a fracture. Fracture is nothing but uh, uh, you know it's a broken of minerals. How it's broken? It's a evenly broken, unevenly broken, or concordal fracture. Okay, there are three types of fracture: even, uneven, and concordal fractures. So let me show you how the different types of fractures. Evenly fracture means if the cleavage is perfect in the minerals. Let's say for example there is a weaker zone here. If I break these minerals with a hammer, it will break perfectly on these weaker zones. That's called a even fracture. If the cleavages are absent, say for example, here the cleavages are absent. You cannot see the cleavage, you cannot see the weaker zones here. So what will do? It will break in unshape. There is no proper shape for that. There is no proper shape for that. So that's we call it as an uneven fracture. Where is the concordal fractures? I will show you the concordal fracture. That is a very typical one. Where is a typical one? Concordal fracture. So this is typical one. We need to show you that. Let me show you that. Sorry, that is not a mineral. Sorry. Okay, I'll show you this later. This. To show you that concordal fracture. Yes, here you can see this. It may not be the properly there. Let me show you some of the mineral if it is there. Concordal fracture. It's just like the curve lines are happening when you break the mineral. It is happening the curve like the marks will be there. Say, for example, when you put the stone in the water pond, it creates some waves like just like rings. That is how it looks in the concordal fracture. So very difficult to see this here. Yeah, exactly. It may not be there like this. I'll show you this Chalcedony. Yes. Yes. Here you can see this. This also not exactly that one. Where is the minerals? Concordal fractures. That is how it looks, the very curved like structure. Okay. Yes. Here you can see this. Okay. See, when you break this mineral here, it's just like rings. Okay, it is how it forms. So that is called typical character of this the fracture. Okay, even, uneven, and concordal fractures. So what do you mean by the diaphanity? Diaphanity is nothing but it's a typical character of the mineral, and it is diaphanity is the ability of transferring the light through the particular mineral. Some minerals are transferring, just like I show you the the what you call this yeah uh, yes. Yeah, this is actually the what you call this yeah, this is a diaphanity property in the minerals. Diaphanity is nothing but transferring, the ability of transferring the light through the particular mineral. That is called uh, what you call this property of the mineral. Say for example, if you take the quartz mineral, these are all the quartz group of minerals. If you take the quartz mineral, say it's a milky quartz. When you cut this, make it thin one, make it thin line of thin sections. I would say in a biology, when you cut the the things in the animals, that's a cross section like that. When you make the thin of this the this quartz, it's a transparent. That's why we use this quartz for manufacturing of glass, because if it's 100% transparent of the light. Okay, some are, and it may not be this 100% transparent. That's how the transparent, ability of transferring the light through the particular mineral, that's called a diaphanity. So some of the mineral quartz minerals are milky quartz, 100% transparent, translucent, and opaque. There are three categories in the diaphanity. Transparent is 100% transferring the light through the particular mineral. So if you take the what you call this this type, this minerals, eh? This is called a microcline, orthoclase, and plesioclase. If it is a partially transferring, it may be partially transferring. When it comes to the iron ore, this is opaque. It will not transfer anyway. So it is just like opaque because of its dull nature. Okay, vitreous. It's not a vitreous cluster. If the vitreous cluster is there in the property in the mineral, definitely there will be a transparent or it may be a translucent. Translucent is nothing but partially transferring the light, and this is iron ore is a completely opaque. There is no transferring the light. So that is a property of diaphanity. Okay, hardness. Hardness is nothing but strength of the minerals, whether it's a hard rock, soft rock, and medium. So high or low. Hardness is high, hardness may be the low, or maybe the medium. So how we are going to distribute this? When you are going to make the the minerals hardness. So I will show you that some of the minerals are maybe very hard. Say this is iron ore. Iron ore in the sense there is the gray black color is completely iron, and this is chert. Chert is nothing but your silica percentage, or it may be a quartz. I would say it's a quartz. Okay, iron ore and quartz. Okay, this is completely what we call this uh, quartz. It may be having the high hardness and low hardness, depends on the capacities. Okay, and these are the another properties. Hardness. Okay, some minerals are very hard, some minerals are very low. That's why I will show you one chart for more scale of hardness. That's a very good part for you guys, and so that you can yeah, it's there in the, I think in the yes, more scale of hardness, especially for how to study the rocks there. Infrastructures. Yeah, as I told you that. Yes. Can you see the screen now? Is it visible? Darshini? Is it visible? Screen. Okay. See
Yes,
here
sir.
the most scale of hardness. There are the hardness in the hardness. There are talc, gypsum, calcite, fluorite, apatite, orthoclase, quartz, topaz, corundum, and diamond. This is a worldwide accepted. This is a Mohs scale of hardness. Just we had categorized this top 10 minerals, and what you have the softest mineral in the world is talc. It's a very soft, and gypsum is harder than talc. And talc is with your fingernail, you can easily scratch it. Generally, that's why we use this talc mineral for manufacturing of cosmetics as well as the powder, talc powder, paste powder. And gypsum is generally it's a little bit harder than talc. That's why we scale down into the two. Hardness scale is 1 for talc, softest mineral in the world, and toughest mineral in the world is a diamond. Diamond can be cut from the diamond itself, none other minerals. Okay, talc is the easily scratched with the fingernail, and gypsum generally we use this gypsum for manufacturing of cement. Okay, and it can be scratched with the fingernail also. It's a very soft one. And calcite is a little bit harder than gypsum, and you need to use with some knife. Okay, fluoride, and it's a 4 hardness category. Rank is a 4 for this. You have to use the iron nail for to scratch this mineral. Apatite is the 5th one. It can be scratched that mineral with a window glass or something else. Okay, and orthoclase, it's with a knife. You have to use the knife to scratch this mineral, orthoclase. And quartz is the you have to use the knife for stress, because the rich of silica percentage here, where there is a rich of silica percentage and there is a high hardness will be there. And next eighth one is a topaz, and you have to use the pen, and corundum is also use the pen, diamond pen knife only, and that's very difficult. Okay, so talc is contains magnesium, silica percentage, and gypsum, calcium, and sulfate, and calcite, CaCO3, calcium carbonate, and fluorate, calcium and fluoride, and apatite, iron, chlorine, and phosphate, and calcium, and orthoclase, okay, potassium, aluminum, and silica, and quartz, silica percentage only, silica only, SiO2, topaz, alumina, iron, it is there. That's why it is a, see here, from this it gets increasing where there is a iron, sorry, the silica percentage, SiO2, and alumina is rich carbon. I mean, that's called a diamond. C is the carbon. It is maybe you have seen this composition in the periodic table in the chemistry, right? It's maybe the magnesium, iron, calcium, potassium, sodium, all these things. Maybe it's a chemical composition of this standard minerals, and it's a chemical composition. This is worldwide accepted Mohs scale of hardness. 1, softest mineral. 10, toughest mineral in the world. That's called a diamond. Okay, in between all these things. In the world, is more than 2,000 minerals are identified, and all those minerals comes in within this category in the top 10. What is the hardness of zone? Hematite. Hematite, it may be a 5 to 6. Depends on the silica percentage, iron percentage. So you can classify, you can fix that, or you can say that high hardness, medium hardness, and low hardness. That is a broad way of classifying the hardness one. Okay, that is the hardness part. And before this, I told you some of the that's called a habit or form. How to identify the minerals in the field and in the laboratory. The habit, some are having the columnar habit, some are having the form. How it looks like this: a laminar, acicular. There are many things are there. Okay, radiating, granular type looks like on the surface of the color is the mineral of the particular mineral of the property, whatever the minerals are there. Okay, streak, I told you that it is a streak mineral, is color of the powder. Okay, luster, it's a vitreous, shining of the mineral. And definitely I told you that transparent, subtransparent, translucent, and opaque. Transparent, 100% translating; subtransparent, partially transferring the light. Some minerals are partially, that's why it's here. Translucent and opaque, completely works. Okay, and fracture, I told you that even fracture, uneven fracture, perfectly cut the minerals the proper shape. And it's unevenly is when you break the mineral, unevenly it's breaking. And concordal, it's just like a waves like this. Okay, that is how the things. Hardness, it's the most scale of hardness that will be there. And specific gravity, weight of the minerals. Some minerals are volume wise big, and weight wise it's a very low, lightweight. That's a specific gravity. And some minerals are showing the that's called say for example magnetite. It attracts the magnet. Okay, and some minerals are like like a calcite. It reacts with the HCl, diluted HCls. And some minerals by fusibility, minerals have behaves differently with the heating and elevated temperatures. Okay, that's how the uh, the mineral properties. So here, these are all the mineral properties. How we are going to identify the minerals. Then chemical composition we cannot identify by looking the it is having the specific chemical composition for that. Okay, and occurrence, where it is occurring, whether it is occurring in Karnataka or it is in any other part of the India and world. Particular mineral. Okay, and how it is occurring is associated with the different rocks that we need to mention that. And industrial and economic uses, what is the use of this particular mineral? Say for example, if we take the quartz group of minerals, what is the use of this, where we are using some of the the manufacturing of glasses, and also the electronics, and some of the used as instrument in ultrasonic equipment. Those minerals also used. And magnetic attraction. Some minerals are having the magnetic attraction. That's called a magnetate mineral. Okay, and I told you that reacts with a diluted HCl. That is called the calcite, rich of calcite minerals, like a limestone. You see the limestones. When you put the the water, it will react like that. It's react with the metals. Okay, and in the next class, we will go to the different these are all the different properties of minerals. Using these minerals, you can easily identify the using this physical properties of minerals, not a chemical properties here. Only physical properties of minerals we are going to identify them. Okay, these are all the properties of minerals. So, for example, I would say when you go to buy a car in the car showroom, what you are going to look this. What is the color? First appearance is the color, whether it's a black, blue, gray, white, whatever things, whatever you like. That's a color. Then it's a habit, how it looks. What is the shape of the color? Car. That is how you are going to classify the things. And streak, you are not going to. So luster, whether it is shining, that color is shining or not. It's a dull color. How it is looks. That is the thing you have to know. That's another properties. And whether it is a hard, the body, the car body is whether it's a very good, very strong metal one, whether it's an air balloon is there in the front. There's many things are you are going to. And what is gravity? Specific gravity. How is the weight of the car? How whether it's a high weight, low weight, and medium. What is a road grip for that particular this one? Those things we are going to analyze this. Okay, and occurrence. What is the Indian made or Japan made or Korea made? How it is? What is a made? Which manufacturing distance, engine capacities, okay, fuel tank capacities, okay, and what are the features in the inside the car and outside the car. This is how we are going to classify, we are going to identify the car, right? Like that, here we are going to identify the minerals. There are we may go to study the 25 to 30 mineral physical properties of minerals. So for all the minerals, these are the properties we need to identify in the particular minerals. Okay, this is all about this class. Okay, Adarsh, Adikeshav, Bharat.
Yes, sir. Sir.
Yeah, tell me if you have any doubts on this.
No, sir.
That's the best example I gave you that, so that you can easily understand yes, how we are going to identify the minerals and what is the use of the minerals. Okay, and detail individual minerals we are going to study in the next class. Have any confusion in the last class to the till the this class? Tell me first, quick. Deepti, Dhananjay, any doubts on this? Okay, there is a quick question, quick quiz on this this session. Okay, the first thing is what is the uses of the minerals? What is the use of this mineral? Any mineral. I showed them many minerals are now, right? What is the uses? Hello? What is the use of quartz mineral? I showed the white one, milky quartz. What is the use of that? What is the economic uses? I showed this mineral. Yeah, manufacturing of glasses and even some ultrasonic the equipments. Okay, and then radio frequencies also we are using this, the quartz one, quad. Okay, and what is the use of this I showed some more another mineral. This one. What is the use of this mineral? Okay.
Marbles.
No. Uses. I am asking the users of this mineral. What is the mineral of this?
Hematite,
Correct. Hematite. What is the use? Where we are using this?
extracting iron.
Correct. Extracting of iron and steel. Right. Okay. This is the thing. And yeah. And this one, very well versed with. Everybody is using in your house. Maybe
Mica.
mica. It's a mica. And where we are using this?
Iron box.
Electrical industries. I would, you can mention electrical industries. It's not only in the iron box. It's because of high heat resistance. It's having very thin layer, but high heat resistance. Okay, this is how the things. So you are familiar with the minerals, a little bit, and the rocks also. So you are in the track, I would say, right? Do you agree with me? Is there any confusion? Because it's a new subject for you, right? So if you have any doubts, just you can ask me, no problem. Okay, right. All right, and yeah, let me take you the the attendance for this.